Hello everyone, and welcome to the first of two presentations covering the topic of physiological stress responses and corresponding effects to corticosterone levels due to anthropogenic disturbances. My first presentation will cover corticosterone levels in wintering northern pintail. The scientific paper that I will be discussing in this presentation is titled, quote, Effects of Anthropogenic and Environmental Stress on the Corticosterone Levels of Wintering Northern Pintails. This paper was published in the Canadian Journal of Zoology in 2014. At the time of publish, the lead author was employed by the U.S. Fish and Wildlife Service at the Sequoia National Wildlife Refuge in Oklahoma. Before we jump into the paper that's the topic of this presentation, I wanted to provide some brief background information on northern pintail for those of you that are not familiar with this species. Northern pintails have a very long, slender body profile, which lends to their nickname, the greyhound of the air. The common name comes from their long, slender tail feather that you can see in the upper right-hand picture. And the males have chocolate brown heads with white neck stripes. You can see the male northern pintail in the upper right-hand picture on this slide. Hen pintails have a very tan, mottled color with a gray bill. You can see an example of a hen northern pintail in the lower left-hand picture on this slide. Males are generally have a longer length than females, with an average length of 25 inches for males and 21.4 inches for females. Males also weigh more than females, with a 2.26 average pound weight for males and females averaging 1.91 pounds. Northern pintail were once very numerous in North America. However, like many waterfowl species, in the 1950s, northern pintails experienced a sharp population decline, and currently the population remains below the long-term average that's set by the U.S. Fish and Wildlife Service through the North American Waterfowl Management Plan. This plan sets population objectives and management goals for North America's waterfowl. Like many migratory waterfowl, northern pintails breed in the northern parts of North America, which includes Alaska, central Canada, and western Greenland, down through the western and central United States. Northern pintails are some of the first ducks to migrate south in the fall, and over half of the pintail population migrates through California and overwinters in the Central Valley of California, and another portion of the population continues to the Texas Panhandle and winters on the Gulf Coast of Texas, which is the subject location of this paper that we will be discussing. Previous studies have found that animals go through physiological changes due to anthropogenic stressors. These physiological changes can lead to increased activity in the hypothalamic pituitary adrenal axis, or HPA for short. This leads to increases in corticosterone production. Just for a quick review, corticosterone is a 21-carbon steroid hormone produced in the cortex of the adrenal gland. The bottom graphic should look familiar, as I got this from a previous lecture, and it represents the production of corticosterone. Increased activity in the adrenal gland releases various hormones, one of which is glucocorticoids, which includes corticosterone. Increases in corticosterone levels is a concern for scientists and conservationists, as it can lead to physiological and behavioral changes in animals that promote short-term survival Examples of short-term survival responses includes suppression of reproductive behavior, suppression of the immune system, and suppression of the mobilization of energy reserves. Increased corticosterone can also lead to an increased foraging activity and increased escape behavior. This leads to increased energy expenditure. However, short-term responses can be beneficial, although prolonged exposure can be detrimental to the survival and fitness of the species. Long-term exposure to anthropogenic stressors and short-term survival responses can be detrimental to the health of animals and ultimately affect the fitness. Examples of detrimental effects of prolonged corticosterone levels include increase in illness and diseases, neuronal cell death, a reduction in fertility, and impairments in growth and development. Studies have found that ecotourism can produce short-term survival activities in waterfowl. These include disturbing courtship and pair bonding, increased flight activity, and altering foraging behavior. The purpose of this project is to better understand what role ecotourism plays in increased corticosterone levels in northern pintail. The study site was located on Bosque del Apache National Wildlife Refuge. The Bosque del Apache National Wildlife Refuge is located within the Middle Rio Grande Valley in New Mexico. This area provides important migration stopover and wintering habitat for northern pintail. Approximately 10,000 plus northern pintail winter on the refuge, with an additional 30,000 using the refuge as stopover habitat. In addition, the refuge is one of the premier bird watching spots in the Southwest, with peak visitation occurring in middle November. Recent studies have shown a lower winter survival rate of wintering female northern pintail on the refuge compared to survival rates for northern pintail in other key wintering areas. The primary goal of this study was to improve the understanding behind the lower winter survival rates of female northern pintails on Bosque del Apache National Wildlife Refuge. To study the effects that ecotourism has on increased corticosterone levels in northern pintail, this project categorized the wetland habitat as either disturbed habitat or undisturbed habitat. Undisturbed habitat were those areas that were 1.7 kilometers away from roads that included public access. Disturbed areas were the areas that were less than 300 meters from roads that provided public access. This study focused on female northern pintails because the females have the greatest impact on population dynamics and improved fitness and recruitment. The pintails were captured using rocket nets in the winters of 2008 and 2009 and the winters of 2009 and 2010. The sample seasons were divided between three periods that reflected high and low tourism. Period 1 covered December 1st through December 19th. Period 2 covered December 20th through January 5th. And sampling period 3 covered January 6th through January 20th. This is table 1 from the report, and it represents the capture date and sample sizes of female northern pintail that were used in the analysis of this study. For the sake of time, I'm not going to discuss every component of this table. You can read through it on your screen, but I think the most important part of it to notice and keep in mind is the baseline sample sizes. And if you'll notice in the winter of 2008 and 2009 section, in sample period 1, that occurred on December 16th and sample period 2 that occurred on December 30th, both had 0 specimens that were used for baseline data for both disturbed habitat and undisturbed habitat. We'll discuss this more in the discussion section of the results, but keep this in mind because we will discuss how this potentially impacted the results of the study. After capture, a USGS leg band was attached to each hen pintail. Recaptured pintails were not used in the analysis section of this study. 250 microliters of blood was drawn from each specimen from the brachial or tarsal vein during 4 different time periods. Those time periods covered 0 minutes to 10 minutes, 20 minutes to 30 minutes, 40 minutes to 50 minutes, and 60 minutes to 70 minutes. The 60 to 70 minute range was used in the analysis section of this study to estimate corticosterone levels. Samples that were taken in the first 3 minutes were used as baseline data, and the goal was to draw blood samples from each time period for a minimum of 12 birds per capture event. After blood was drawn from each specimen, it was placed in a compartmentalized box that limited light and movement. After all the blood samples were taken, the specimen was released. The blood samples were kept in ice for 2 to 6 hours and then centrifuged for 5 minutes. The plasma was removed and stored at -20 degrees Celsius until analysis. Carcass fat was estimated using the Model 3 equations that was derived by Smith et al. In 1992. Corticosterone levels within the plasma was measured using radioimmunoassay techniques defined by Wingfield and Farner, 1975. 2 samples of 10 microliters of plasma was mixed with 0.5 milliliters of double distilled water and equilibrated in a 4 degrees Celsius refrigerator overnight with 2,000 dpms of 3H cortisone. Only hatch year females were analyzed due to small sample size of after hatch year females. Comparisons between years for sample period 1 was not tested due to no samples obtained for disturbed areas in year 1, and regression slopes between years and classification were tested separately using ANOVA. When evaluating the effects of stress on corticosterone levels, this study found no interaction between the capture time and the capture year. There was also no interaction between corticosterone levels for the capture year, capture season, the habitat classification type, and the time period of capture. There was no interaction between the habitat classification type and minute for sample period 1 through 2009 and 2010. However, there was a capture year and minute sample interaction for corticosterone levels for sample periods 2 and 3 in years 2009 and 2010. The study also found that baseline corticosterone levels were similar between the disturbed and the undisturbed classification areas. Figure 2 in the upper right-hand corner of this slide represents the corticosterone levels for years 2008 and 2009 in the solid line and years 2009 and 2010 in the broken line. And you'll notice in the years of 2009 and 2010 sample times, there's an increased levels of corticosterone starting in the middle of the 20-minute and 30-minute sample period. And the reasoning behind this we'll discuss in the results discussion section. This study also evaluated the effects of body condition and time of year on corticosterone levels. And the results of that are represented in figure 3 on the right-hand side of this slide. The top figure, or figure A, shows a relationship between capture date and maximum corticosterone levels. And figure B shows the relationship of total carcass fat and maximum corticosterone levels for the winters of 2009 and 2010. And the study found that the capture date was negatively correlated with total body fat, which is represented by figure B on the bottom, and corticosterone levels were positively correlated with the capture date, which is represented in figure A, the figure on the top. In contrast to other studies, this study found no evidence that ecotourism causes a physiological stress response that leads to increased corticosterone levels in female northern pintail on the Bosque del Apache National Wildlife Refuge. Previous research has demonstrated a positive relationship between tourism disturbance and elevated corticosterone levels. However, the study did observe a stress response between years 1 and years 2. And factors that may have influenced the results of this study include hatch year northern pintails may lack a response, a physiological stress response to disturbance. They may move away from disturbance before corticosterone levels can increase. Northern pintails are a game species and are hunted during the waterfowl season. They may have adapted to avoid a stress response to disturbance. However, I think it's important to point out that hunting is not allowed on the Bosque del Apache National Wildlife Refuge, but the specimens in this study were hunted as they migrated down from Canada through the United States. And the last factor, if you remember in the sample years 2008 and 2009, for the first 2 sampling periods, there were no specimens collected with baseline data. So the baseline sample size was too small to accurately measure baseline corticosterone levels between the areas with and without tourism impacts, which could have influenced the results of this study. And the study found that the greatest response in corticosterone levels distress occurred during the winters of 2009 and 2010. And this coincided with the time period with the lowest temperatures of the 2-year study. So the authors of the paper hypothesized that stress responses coupled with harsh environmental conditions was likely the cause of these increased corticosterone levels in 2009 and 2010. However, additional studies, more in-depth studies, need to be conducted to confirm that hypothesis.